In this video, I'm going to show you an example of finding partial derivative of a function with one special trick. The function f is given 4x times x to the 2 plus y to the 2 to the power of 5 over 2 times by e to the power of tangent of xy to the 2. And we want to find the partial derivative of this function f of x with respect to x at the given point 1, 0. So at the end, we want to plug in 1 for x and 0 for y. So we want the partial derivative value at this point. As you can see, this is a really complicated function. 4x times x to the 2 plus y to the 2 to a power times by e exponential function to the power of tangent of xy to the 2. Of course, you can take derivative of this expression with respect to x, then plug in the values. But it would be really hard and it needs lots of calculation to do. But if you know one special trick, then you can find the partial derivative of this function with respect to x at this given point 10 times faster. But what is that trick? Attention, the question is not to find a partial derivative of f with respect to x in general. We want to find the partial derivative of f with respect to x at this point. Why the question asks us to find the partial derivative at this point? Attention, you want to take the derivative of this with respect to x, and x is the variable. What about y? Y is a constant. You know that when you take derivative with respect to a variable, the other variables are constant at that moment. So at the end, we want to plug in 0 for y, and y is a constant. So instead of using this number for y at the end after you took derivative with respect to x, what is the better idea? Plug in this 0. Attention, you cannot plug in 1 for x because x is variable for us for finding partial derivative with respect to x. But 0 for y is a constant at the process of finding partial derivative with respect to x. So do not use 0 for y at the end of the process. Instead of that, plug in 0 first for y in the function, and it simplifies hopefully the function, then take partial derivative with respect to x. So we solve this question in this way. First we plug in 0 for y because we want to find the partial derivative with respect to x. So we have nothing to do with y. Y is a constant, and because y is a constant, we plug in 0 for y first. So basically by plugging 0 for y, then we have what? This expression would become this: f of x comma 0, we plug in 0 for y, it would be 4x times by x2 plus 0, which is just x2 to the power of 5 over 2 times by e to the power of tangent of y is 0, so tangent of 0, because 0 times x is also 0. But we know that tangent of 0 is 0. E to the power of 0 is 1. So our function would be 4x times by x2 to the power of 5 over 2. Power to the power multiplies. So this equals to 4x times x to the power of 2 multiplied by 5 over 2 would be 5. So finally our function would be 4x to the power of 6. Now take derivative of this. Now from this we take derivative of f. F is this at this moment with respect to x would be 24x to the 5. 6 goes in front, subtract the power by 1. Now plug in 1 for x. Now if we plug in 1 for x, f of x, partial derivative of f with respect to x at 1, 0 would be just 24. We plug in 1 for x, 1 to 5 is 1, 1 times 24 is 24. So what we learned from this question: when you want to find the partial derivative at a specific point, at a given point, you can use this trick. Plug in the constant, the variable that is constant. Here we want to take derivative with respect to x, so we cannot plug in 1 for x. But for y, first we can plug in this value, then just take derivative with respect to x, and at the end plug in the value of x also. I hope you enjoyed this video. Please subscribe in my channel and see you in the next videos.